me to speak like this or with a microphone?
Microphone.
Microphone. To bring it down, a bit short. So as you can see, my title is I'm a Solutionist. There's enough people in the world talking about the problems, and that's never really been my interest. It's much more about what we can do rather than what we can't do. And for those of you wondering what's a biophilic, it's a lover of nature. So that's the first question. What is nature? And so often people point to the green bit and they say, well, it's the forest, or the sky, or the water. And they forget that us, humans, we are just another species on this planet. We are nature. We are not separate from it. And recently I was contacted by Lawyers for Nature, who actually want to change the definition in the dictionary, because if you read the dictionary's definition of nature, it says excluding humans. So because we haven't felt a part of it, it's meant that we can take from it. So putting ourselves back into remembering that we are just another mammal here on this earth. And we're all trying to do the same thing. We're looking for a home to keep warm, to have offspring, to find food. All creatures are doing the same. But first, I'd like to acknowledge the indigenous peoples who I have spent over 20 years working with. And not only have they lost a lot of their land, but they're losing their language and their culture. And their language is what holds so much of the wisdom. And there is so much that we can learn from them. So I'm going to break this down into 3 areas. What does it mean to be a solutionist? How can we learn from the natural world? And what does it mean to have systemic change? So this is how it started. I was asked recently, have you got any photos? So I kind of looked back and I found this picture of me with a baby anaconda. And so in 2000, I was asked by 5 international environmental groups to spend 6 months living in an isolated lagoon in the Ecuadorian Amazon. And my job was to find the pink river dolphins, because the oil industry wanted to drill in the same lagoon that the dolphins lived. So the environmental groups were wanting to protect the area for the dolphins. This is freshwater dolphins. And so that was how I spent 6 months in that little boat. I was just out filming to collect the graphics that could prove that the dolphins were there. And it was an amazing opportunity to be able to immerse myself deeply in the Amazon. And people would say, wow, you're so lucky, and if I wasn't in that picture, you'd have no idea how big the tree was. People would be like, well, to spend all that time in the Amazon. But I'm not ever there as a tourist, just going and having a look at the beauty of the forest. Instead, what I uncovered is one of the Amazon's dark secrets. It's actually got the largest oil spills on the planet. So please raise your hands. How many people in here knew that the biggest oil spills on the planet are in the Amazon? Nobody. We live in a world of social media where we think we know what's going on. And if I said, what's the threat to the Amazon? You'd probably say the trees are being cut down, deforestation. We wouldn't say that actually the legacy of Chevron Texaco, and it is the largest environmental lawsuit in the world. And we won. Chevron Texaco were ordered to pay $3.5 billion to clean the mess up, but they've never done it. So it remains 1,000, just under 1,000 pits, the size, each one, of an Olympic-sized swimming pool. So that was what I discovered, and that the highest childhood leukemia in the world is the indigenous children of the Amazon. How can that be? And so also, there's regular oil spills. So you can see from this river here that when the water has dropped, the oil just lines the banks of the rivers. So I decided I was going to make a documentary, and I went from the headwaters in Ecuador all the way down the Amazon River to Brazil, and I made the film Blood of the Amazon, because to the indigenous people, they call the oil the blood of the earth. So as a solutionist, this is a lot of problems. You know, what do we do? I mean, for a lot of people, they would just turn away and go, hey, it's too big a problem. What can one person do? And this is what I've heard a lot. I'm just one person. I can't really do anything. So I just want to show you a few of the projects which I've started. So firstly, I founded the Amazon Myco-Renewal Project and brought together a team of scientists that know about myco-remediation. That's the use of fungi to break down contaminated land. So a mushroom's job in the forest is it breaks down twigs, sticks, carbon. Oil is a hydrocarbon. So it's able to break down. The enzymes in mushrooms are able to break down oil spills. We were able to show that on a small scale. What we need is huge land-moving equipment to be able to do it on a large scale. But the imminent need was for water. And that's why myself and one other woman decided to build rainwater systems for the families that were most in need. And just the two of us, we would kind of arrive in a community and we would work with the locals. So that, as you can see, this rope was as near as it gets to the health and safety. And we would teach them how to build rainwater systems. And that was kind of, 200 systems. Feels like nothing, but it's better than nothing. And you can see how close this woman is to a spill. And that's where she's getting her water from. Water for drinking, for cooking, for washing. So it's so close to the access to their wells. But this water system, I passed by 12 years later after making it, and I popped in to see the family, and I was like, oh, how's your tank going? I was having a look, and they said, well, we've had to replace the roof, but thank you so much, because before, our children used to have to take a lot of medicine, and now they don't have to take anything. And the simplicity of what we take for granted, drinking clean water. But with the modern technology of the oil industry, we wouldn't expect to see that this is a modern day oil spill and what the oil industry do to stop it going downriver. It's not really very high tech. So it's a constant thing that is happening, not just in the Amazon, but all around the world. And when we talk about the need to stop fossil fuels, stop burning carbon, rah-de-rah, climate change, we're often thinking of the end result, the burning of it. We're not thinking about where did it come out of the ground. And that's what's really important, to understand where the origin of mining comes from. And we can also forget what plastic's made out of. It's made out of that very oil. The same, it goes in your car, that's what plastic is made out of. It's made out of fossil fuels. And if we throw a plastic bottle down, it'll be there for 400 years. So what do? I learnt about eco-bricks. So I started going to some communities where there was a lot of rubbish and teaching them to get an empty plastic bottle and to shove all the plastic bags and the plastic straws and put it into a bottle and turn it into a brick. And with that, that's a health centre that we built there out of a village's rubbish. So it was good to be able to go in and see just rubbish full of the river, rubbish everywhere, and to be able to transform that into a building. But of course, working in the Amazon, the big thing is deforestation. And what we have is this slash and burn, which is what happens in the tropics all around the world. It's really poor soil. So they cut it down, they burn it, and then they have lovely ash to grow their crops. But because it's the rainforest, it rains a lot, and then the rain washes away all the soil. So then they can't grow any crops anymore. So they have to keep burning more and more of the forest to be able to survive. So when I learned about agroforestry, this form of growing this particular kind of tree in alleys, and the reason that we grow them in alleys is because then we cut them down. We actually pollard them. So we cut it, and then we drop all of this between the alley, and all of those leaves turn into compost, and within 6 weeks, they can grow their crops in the middle of the alley. And this is what we're seeing, an amazing abundance, a really high yield, without them needing to spray or use any agrochemicals. And one of our really exciting, Does anybody in here like chocolate? Well, there's a very sad story, because we might lose chocolate because there's a fungus, Monilla, and that fungus is just wiping out cacao pods, because cacao originally came from the forest, and we've taken it out of the forest, we've turned it into a massive monoculture, and that means they have to spray it with a lot of fungicides. And we accidentally found out that this tree that we use, Inga edulis, any cacao that is growing alongside our system seems to be free of Monilla. And I'm working with Reading University, so we're hoping, we've got 6 PhD students that want to go down and actually research this, because this could be a game changer. But another big mover for deforestation. We live in a world of supply and demand. And about 6 months ago, a friend sent me all these photos and she said, "Oh, Nicola, they're clearing loads more area now." And when we think of, well, what are they clearing it for? We think of cattle or soya or palm. But this is for taro. And it's a root crop. Well, where are they sending it? They're sending it all to Europe and to the USA. Well, hang on, I don't know anyone that eats taro here. So I had to do some research to find out, why are we importing all this taro? And it's actually the vegan plant-based diet. So on one hand, we know we have to reduce the amount of meat we eat. That's a fact. But eating processed food, where we don't know what the ingredients are, that's the difference. What we want is a whole food plant-based diet, not a processed diet, because this is what's also driving more deforestation. And this is really what keeps me going, is that how can we keep this ancient forest standing? And I'm really lucky to get invited out to some Indigenous communities. So this was the Siona people, and I was invited to one of they're called Mingas, which is a community work day, and everybody turns up. It wouldn't be okay to not turn up. Everyone is there, the whole community. And one month it might be fixing the roof or the bridge, another month doing a big harvest. But that is what creates a resilience in your community. If you know all your neighbours and you will help each other out, and then after you've done a few hours of work, you then share food. And this is traditionally, when you've got no electricity, how you still cook. And no blenders. So here she is using an old boat, mashing up the chonta, which is this fruit which they're celebrating. And they then turn this into an alcoholic drink. But they also still know how to make clothes. Now, what would happen to most of us here if there was no clothes shops open? How many people here know how to make their own clothes? So to be able to still have that knowledge passed down to them of how to actually be able to make what they need. And there's something really different when you look in these children's eyes. There's no such thing as anxiety or depression. You don't hear about suicide in Indigenous communities. So what is the difference when we're hearing here that we have an epidemic of depression? And there's so much that we can learn. And people talk about nature deficit disorder. The most important thing is to be able to get outside. And that's what they do. They live outside. So leaving the Amazon and coming over the Andes to the other side is the cloud forests. And actually the cloud forest is much more biodiverse than the Amazon itself. But not many people know about the cloud forests. And I was asked to go to this place, the Los Cedros Biological Reserve, to write a report. So I thought, I'll go up there for 5 days. And then COVID hit. And my 5 days turned into 5.5 months. This is my jacuzzi. And so I'm hearing about the horrors of lockdown, and I am in officially the most biodiverse place in the world for 5.5 months. And all the scientists just said, take photographs of anything that you see, and we will identify it. Because there are so many things in Los Angeles that still don't have a name. I don't know why, it's just running away with me. But they're also pretty weird insects. Every day I would see something different, the weird and the wonderful. And the scientist said to me, look, just anything you take a picture of, put it on iNaturalist. And there are over 500 observations that I photographed, and still some of them nobody knows what they are. They're still not identified on my iNaturalist page. But this was also, just to put that into proportion, that's a chopping knife, and that's a giant cockroach running around in my kitchen. And that caterpillar, which I accidentally touched by accident, and I felt this pain go up my arm, like pain I have never experienced. I was begging them to cut my arm off with a machete. 24 hours, and it didn't matter what I took, nothing would take the pain around. And nobody has been able to tell me what that caterpillar is. I've contacted every moth and butterfly expert, and nobody knows what it is. But whatever that poison was, we've got no idea. And what potential that has also in the future. But to live in a place where you could actually swim and drink the water at the same time. But we're in this place where we've got this crazy tree planting going on, whilst all the forests are being cut down. We need to move this so that we, first of all, we protect these precious places like Los Cedros. Then we tree plant. But at the moment, we're doing it the other way around. We're actually focused much more on tree planting than we are on ancient forest protection. And the amazing place of Los Cedros, whilst I was living up there, I then discover that this is what they want to turn it into, a copper and gold mine, right under the middle of the heart of Los Cedros. Because we all want our gadgets, and whether that's smartphones or electric cars, they all have copper and gold in them. And so they are looking for more and more places to mine to keep trying to look for more copper and gold. So we ended up going to court under the rights of nature in the Constitutional Court of Ecuador, and we actually saved that forest, which was great to be part of a big win and a precedent-setting case. But mining is seen in many aspects. In our rivers, in all the fashion that is just being dumped, our oceans, even our planet. We haven't done just like dumped it here on Earth. We've managed to got so much dead satellites going on around us. So really, I sometimes think if there was some other, alien species looking down at us, what would they think? Humans are a very young species. We're the only species that foul our nest. We have to learn that this isn't okay. Single-use anything is not okay. We're just buying too much stuff and dumping too much stuff. But this is nature's rubbish, nature's waste. Those bluebells will return to the forest and feed the forest. The shell will go back to the sand. But if we look at human packaging and nature's packaging, nature's doing the same thing. This is packaging. Nature's really good at packaging in so many aspects. It's even so intelligent, the bananas and some fruits, they change colour to tell you when they're ripe. So you can see we've got so much to learn from a packaging which you can throw it on the ground and it would just disappear. So there is a movement to look for different kinds of non-petroleum-based plastic, bioplastics, this that's made out of mushrooms, or the ball, which is made out of algae, and it's a water ball, and you just eat it. So you just eat the packaging. So because recycling is not really the answer, yes, it's better than nothing, obviously, but it also perpetuates consumerism, because we keep buying loads of stuff and just putting it in the right coloured bin and feeling good about it, rather than actually stopping buying the stuff in the first place. which is why these refill centres are so important. And there are organisations like this new Outlander that have worked out from beer waste how they can make all this bioplastic. Because what we don't want is bioplastic made out of cornstarch and potato starch, because that's food. We don't really want to be turning food into plastic. It's a much better idea to be turning beer waste into plastic. But some companies have really got it down. This is a beer company that has no waste, because the beer waste is then they're making bread, they're growing mushrooms. When that's spent, they feed that to the pigs then create waste. So this beer company is selling beer, bread, bacon, mushrooms, compost, gas. Now, does that look like a good business model? No such thing as waste. We turn trash to treasure, rubbish to a resource. We have to just change the way that we look at it and move from this old way of, mine, deplete, deforest, degrade, to where we are now, which is sustainable. We don't really want to sustain this, what we have right now. Reduce, reuse, recycle is the mantra. What we really need to move on to is we need to regenerate this planet. We need to rethink the way we are, to restore, to rewild. There's so many other positive ways that we can move forward. But when we think about the future, if I asked you, what does the future look like? Quite often people have quite an apocalyptic view of the future. Hollywood has not given us very many positive outcomes. It's either zombies or vampires or some kind of major breakdown. But could we actually imagine a different future? Because if we can't see it, we're never going to get it. Which is why it is so important. If there's any artists out there, musicians, we need to be seeing it visually, talking about it, singing about it, knowing that another world is possible. Because when we have a look at the future of cities, we know that this is what they're going to look like. Yeah? The future of cities are going to be green. Why? Better air quality, better for our mental health, more biodiversity. But also it makes sense architecturally, is that they cool the buildings in the summer and they keep them warm in the winter. So this is what we are needing to be moving towards. So how can we learn from nature as the ultimate teacher? 3.5 billion years of evolution, we've got a lot to learn. So how many people have heard about biomimicry? Just only a few of you. This is where it is at. Biomimicry is totally amazing. Innovation inspired by nature. For a long time we've just not been asking the right questions. How do they do what they do? So the most famous example really originally was Velcro. NASA needed something that would stick things down. And this Swiss scientist was walking along and he noticed these burrs stuck to him and his dog. And he looked at the burrs under the microscope and he saw the little hooks and he replicated it and he created Velcro. But the first step is learning from nature. But what's it made out of? Petrochemicals, still made out of oil. So we still haven't moved to that second part. But what we really need to do is see differently. The old way, we all just want to learn about it. What's the name of that? What's the Latin name of that plant? And what does it do for me? But instead, how about we learn from it? And we ask the tree, hey, we still don't know. How do you pump water right up there? If humans wanted to pump water right up there, we need a lot of power to do it. How do trees do it? So there's so many questions that we still have to explore to be able to become more efficient. Because this idea that sustainability is a new thing, it's been around forever. We're just kind of like late catching up to it. So if we look at nature's design, if anyone's ever seen a coral reef, but it just kind of comes out of thin air. It's just made out of the ocean and carbon dioxide and calcium. It's built to shape, on site. There's no waste. They're not shipping it around the world. Using CO2, which we want to be using, get it out of the air. And it's a 450 million year old process. So this is how nature builds. In comparison to how we build, if we look at the concrete, where we heat it and we beat it and we treat it, we use really high temperatures, really high pressures, and it's a very toxic chemical process. And we know that concrete is one of the worst things for climate change. So this is the way humans are building right now. We're building everything out of concrete. So what does that mean for the future? So there are businesses that have learned how to capture carbon from the atmosphere, blend it with seawater, and turn it into a building material. So how cool would that be if we actually had like these manufacturing plants around the place that were just making on-site concrete by this process just like the coral does. So when we talk about biomimicry, we look at it in three areas: in form, process, and system. So form, a classic example, is the kingfisher. So if you know about the Japanese bullet train, it had a real problem when they developed that train. No, it wasn't too fast. It was that every time it came out of a tunnel, it made a sonic boom. So the neighbours were not happy. So they had to go back to the drawing board, and luckily one of the engineers was a bird watcher, and he noticed that a kingfisher can dive in the water without making a ripple from one density to another. So that's how they developed, changing that train to have a really long nose so it could come out of the tunnel. There was no sonic boom. But the side effects were that it went faster and it was more efficient and it saved money. So these are these win-win, turn to nature to solve a human problem. Process. If you've ever tried to get a limpet or a mussel off of a rock, it's hard. And it's not, they haven't got like a little suction foot. They create a glue. They create a protein-based glue. What do humans make glue out of? Come on everyone. Petrochemicals. It all comes back to those original pictures of the oil industry. That's what it's all made out of. We need glue for everything. So some scientists have asked the mussels, how do you make this glue? And they've worked out what the protein strain is, and they've made a natural glue, which has got huge potential for the future. And surgeons have actually got very excited. It is the future of internal surgery. Naturally gluing ourselves together. But there's so much potential for us to have a natural glue. And a system, we're looking at the whole picture. How does a forest or a coral reef, or how does it all work together in an entire system? But one of the creatures that are most evolved are sharks. They say they can't evolve anymore. And if you look really close at a shark's skin, nothing ever sticks to a shark. All the other creatures in the ocean, if they're slow, things, barnacles and all sorts, but not on a shark. So when you look at the dentricles on the shark's skin, the form means that just nothing can stick. So this company, Sharklet Technologies, has developed a surface. So imagine in hospitals or restaurants, what do? They spray it with petrochemicals. And they spray it with all these chemicals to try and kill all the bacteria and the viruses. But what about if we just change the surface so that no bacteria is stuck to it? It's a different way of thinking. Speedo also developed a swimming costume that got banned in the Olympics because it just wasn't fair. Based exactly on the shark skin. Sunscreen. Hippos wallowing around in the African sun. They don't get burnt. What is this natural sun protection that they create? We smother ourselves in petrochemicals. There's a story here, isn't there? It's kind of like you just keep repeating yourself. But sometimes we just don't think about where this stuff, where it came from, and how it's in all of our lives. But learning from nature, you've probably been to London, and you've seen the gherkin, but it really should not be called the gherkin. Its actual name is the Venus flower basket sponge. Slightly more long-winded, but that is exactly what the architects who built the gherkin mimicked. They used exactly this. Why? Because it's better resistant to wind loads and natural ventilation through all the floors. It is has extra stability, and it has an open floor plan. It doesn't need to have loads and loads of columns in it. Another example we've got in Zimbabwe is this amazing building, the largest commercial building that has mimicked a termite mound. So these architects, they were told to build a building with no air conditioning in it. Air conditioning is expensive, and actually it's the #1 worst thing for climate change. HFCs, hydrofluorocarbons, way worse than carbon dioxide and methane. So as we're moving into a world where it's getting hotter and everybody wants an aircon unit, how do you build a building with no air conditioning? You ask the termites. The termites know exactly how to create natural air conditioning. They have a fungus which they need. They are the best kind of like agricultural farmers. And they need to keep their fungus at exactly 87 degrees. So it's really hot in the day in the desert and really cold at night. And they need to keep it at a stable temperature. It's also like a human lung, which is amazing. It breathes in fresh oxygen during the day, and it breathes out carbon monoxide at night. This ventilation system inside the termite mound. There's a very cool YouTube video where they actually poured loads of concrete down a termite mound, and then they excavated it, and it is massive. And that's how they learned how to build a building. It doesn't need to vent itself. Uses 35% less energy, and it saved $3.5 million on not having air conditioning. So, it's a win-win. This is the technology we need to be learning about. But it's been around us for a long time. We all know about LED lights, but LED lights did not work because they were so small. And in the end, one of the scientists were like, well, how do those little fireflies, these tiny little beetles, how do they shine so bright? So they looked at their stomach, and they found that the stomach wasn't round, it was jagged, more surface area. So as soon as they changed LED lights to have a jagged edge, then they shone. So we've been looking for a long time. And now we've got Exeter University looking at butterflies. A little tiny butterfly really knows how to absorb the sun. It is so solar efficient. Do angles make a difference? Yes. Butterfly doesn't just hang out. It holds its wings at 17 degrees. Because at 17 degrees, solar comes in and bounces off its wings, and it heats up quicker. Oh, does that mean if we moved our solar panels, they would heat up quicker? So we're starting to get the evidence that the answers are all around us of how to become more efficient. Also, if you look at a butterfly, they don't weigh very much. There's not much of them. It's all holes, whereas our solar panels are heavy and solid. We could make them out of like nanoholes. Wind turbines. Again, super inefficient. Who do we learn how to improve a wind turbine from? A whale. A whale has to jump up through the water into the air. And so it has developed that it has a wavy edge on its fin. And that means it cuts through the water better. So propellers on boats, fans in computers, if they had wavy edges, hugely more efficient. So we can see the pattern over and over again that we've got so much to learn. When I look at these, I see these morpho butterflies in the Amazon, and they're waterproof, they're these huge butterflies. And I think, hey, I want to have a beautiful turquoise waterproof jacket. But what would it be made out of? We can't just make a natural, beautiful turquoise jacket. How do the butterflies do this? Colour is structural. They don't dye themselves. But we're looking into now colouring things with microbes. Because pretty much everybody's clothes in here have been dyed with a toxic colour, which ends up in the rivers. So we need to move on from that and find different ways of creating colour. So we see these beautiful dragonflies and birds and all the bright colours in nature. And there's no dye involved. But we're using 750, 1,000 metric tons of coloured dyes. They even say that in some countries you can tell what the fashion is for next season depending on what colour the river is. Yeah. It is shocking. So we have to find other ways. And sustainable fashion, it's a big one, because it's either made out of cotton, and cotton uses loads and loads of water, and also cotton has to be so sprayed because every little insect wants to live in a cosy little cotton ball. You imagine how cosy a little cotton ball is. So they have to keep spraying it with pesticides. And apart from cotton, probably the majority of the clothes in here right now are all made out of petrochemicals. Acrylic, polyester, nylon. So what does the future of fashion look like? We're going to be looking in a very different way. So what about we ask the spiders? Hey, how do you make the strongest material known? Spiders' web is stronger than steel. Or do we just kind of put millions of spiders in a warehouse and then make these beautiful fabrics? Or do we actually just ask the spider, hey, out of dead flies and water, how do you make this stuff? And that's what's been done. North Face has made this jacket, Stella McCartney, so already fashion designers have learnt about this new human-made spider silk. 5 times stronger than steel, 3 times stronger than Kevlar, and imagine withstanding temperatures up to 300 degrees. I mean, it is like a super material. So this is where fabrics are going. Or vegan leather made out of pineapple waste. Just like leather, but made out of pineapples. Or, has anyone drunk kombucha? Yeah? Well, that is kombucha, mushroom, fashion. So the future of fashion, made out of mushrooms. And you can grow it to any shape you want. But, I've been a mushroom lover for a long time, going back to cleaning up oil spills with mushrooms. And now I'm saying, wow, we can actually get dresses made out of mushrooms. We can have packaging made out of mushrooms. We can have building materials made out of mushrooms. There's a great book and it's called Mushrooms Will Save the World. And I thought it was a joke, that title, but actually I'm starting to realise that it's probably true. There's so much that kingdom, the fungi kingdom, can teach us. So if you want to learn any more about biomimicry, go to the website asknature.com, because Ask Nature is exactly what it says on the can. But going to your chemistry lessons, remember that there are 118 elements, all those elements, and nature only uses 28. So that's from the hardest shells to us, to jelly, mushrooms, everything that you see in nature, everything, all around us, everything, is only using 28. Humans, we're using pretty much most of the whole of the periodic table. And the problem is, a lot of them are supposed to stay down underground, because when you bring them up, it's really difficult to deal with them. So how can we learn to build everything around us using only 28 elements? But this is really what everyone needs to learn. These are the principles. If we can all just kind of imprint this, we're on for a good future. To replicate exactly what nature does. It runs on sunlight, uses only the energy it needs, fits form to function, recycles everything, rewards cooperation, banks on diversity, demands local expertise, curbs excesses from within, and taps the power of limits. So that's really the 101. But finally, I just want to talk about systemic change. What do we need? We need social change, we need political change, individual, legal, and economic. And if we get all that, then we can smile. So that's really where we need to come into that individual. Because I don't want to talk about the horrors of climate breakdown. It's not even called climate change anymore. It's officially called climate breakdown. It's happening all around us. It's now 99% of scientists that are in agreement. 1%. So, we don't really have to debate whether or not it's really happening. What we need to know is what can we do about it. Because we have done a really good job of wrapping our beautiful planet in a big duvet of petrochemicals. And that is what we have got to urgently sort out. So, as an individual, you make those choices about what products you buy. Do you shop and buy new fast fashion or from a second-hand shop? Do you use public transport? Can you have holidays at home rather than flying? These are all things which we really, really need to consider. But there are so many parts of the solution. Every one of these is something that we can do as an individual to make the world a better place. So myself and Sussex Green Living, we go around to schools as well, and we do whole days of environmental education, making it fun, not talking about the doom and gloom, but really being proactive. How can we encourage you to get involved and getting your hands in the dirt, getting involved with local wildlife trusts and rewilding projects, because that's what the earth needs. It needs all of you to help out. And we do it in whatever way we can, whether I'm standing here giving you a talk now, or whether I'm up on stage playing in a band, then I can use my voice wherever I am and wherever I have a microphone to be able to speak out. And that's what, again, if we've got any musicians in the room, hey, use the microphone. This was when I played in Ecuador, and there was the president of Ecuador in the front row, and I was able to say something, which I wouldn't have otherwise been able to get to him to speak to. So we use that way. But it's really important to have a vision of the future. A land that we can be proud of, that all of us can do something about. So I'm going to finish there. It's been a big download for you. So I hope you've learned something new maybe there, and see that another world is possible in the future, but it does take us all to do something. So I'll open up for if there's any questions, and I don't know.